Algebra 1, Section 9.3, multiplying with binomials. Taking a look at the first example, this is what some textbooks would call the extended distributive property. We're basically going to be doing the distributive property, but kind of more in a more comprehensive way. This particular example is what is commonly referred to as FOIL. Here's why. If I'm going to multiply, and what you're going to do is multiply every term in the first set of parentheses by every term in the second set of parentheses. If I'm going to multiply 2y by y, those would be those two terms would be respectively in the first position of their set of parentheses. That's f. If I'm then going to multiply 2y by 2, then you're going to be multiplying the term that's on the far left by the term that's on the far right. You might say that those are on the outside. That's the O. These two terms then would be on the inside. That's the I. And then the -3 and the +2 are in the last position in their respective binomial, in their respective parentheses. They're last, so that's L. If you've ever heard someone refer to FOIL before, the acronym comes from what I just explained to you. Okay, so as I multiply 2y by y, you're going to get 2y squared. As I multiply 2y by 2, that would be 4y. And then I'm going to jump over and I'm going to multiply -3 by y. That would be -3y. And then -3 multiplying 2 would be -6. Now, oftentimes, not always, depends on the problem, but oftentimes the middle two terms are like terms and we should simplify them. If you don't do that, that's not going to be considered standard form. That's not going to be correct. We do want to simplify that. This simplifies to 2y squared plus y minus 6. Incidentally, if you read examples in your book, you will see some examples where they are doing a different method than this. There's a vertical method. If you searched it out on YouTube, you'd find some kind of a box method. I am not a fan of these methods. I don't think you're setting yourself up for success later in the chapter with factoring, which is a huge skill that you need to have. You're going to want to be able to do this horizontally. This method right here that we just did, this is considered horizontally. And the correct answer is 2y squared plus y minus 6. Next example. We'll do that again real quick. Multiply here, you get 12x squared. Then multiply here, you get -24x. Then the O in FOIL would be +6x. Then the L in FOIL would be -12. Look to simplify these two middle terms again. It's not always the middle terms, and they don't always simplify. It depends on what the variables are in the two binomials, but oftentimes, I would say probably 95% or better of the problems I'm going to assign you in this chapter like this are going to have some combining of like terms. This would be 12x squared minus 18x minus 12. Okay, next example. We're going to skip over this one for a moment and go to the last one. And the concept is exactly the same here, but it's not considered FOIL because, again, as I said in the FOIL problem, you're going to multiply every term that's in the first set of parentheses by every term in the second set of parentheses, and that's just more than 4 multiplications, right? So you don't have FOIL because that's only 4 letters. But what you're going to do is the same. You're going to multiply here and then here. And then after we get those two terms, we'll multiply -2x by both terms. And then after you get those two terms, you're going to multiply the last term 3 by both terms in the second parenthesis. And when we're almost done, what we'll have is 6 terms, and then we'll look to simplify that down. All right. So what do we have? We have 3x squared times 2x. That'd be 6x to the third. Be very careful with the exponents, right? X squared times x would be x to the third. 3x squared times 7 is 21x squared. Then I jump over to -2x, and I'm going to do 2 multiplications. That's -4x squared and -14x. And then I jump over to the 3, and it's 6x, +6x, and +21. Okay, so we want to look for like terms then. And what I see here is a couple of x squared terms. Those are alike. And then what I also see is a couple of terms with x to the first power. Those are alike. There is nothing alike with x to the third. There's nothing alike with the constant 21. So we write 6x to the third plus 17x squared minus 8x plus 21. Okay, now you can see the method that they have right there is somewhat of a vertical method. I've already said that to you a couple times. I don't like it. And we're not setting ourselves up for success later in the chapter. I know what's coming. You don't necessarily, unless you've read ahead. But don't do that. I would highly discourage you from doing that, but rather being able to do this with a horizontal method. Now, I will say that you certainly could flip the parentheses around, and that would be more comfortable for me. Rather than doing it the way I did it and getting this as an answer is correct, you'd get the same answer if you go ahead and just flip the two parentheses around. In fact, when they show their horizontal method, that's what they do. They put the binomial first, the trinomial second. This that they're showing here, the horizontal method, is a little bit more work shown of the same way that I just showed you. And then when they simplify, they get the exact same thing that we do. Okay, now if this were an in-class lesson and we were doing a little bit more of an investigation, it would have made sense to do example 3 first and get you thinking about area and then apply it to the multiplication. I decided to do that in reverse order here because of the online nature of this lesson. And now let me just point out that you can apply an area problem to that multiplication. So let's just suppose that this is some kind of a blueprint, right? So there's a building, okay, that has some like a courtyard or something, right? So there's area that wouldn't count in square footage in this space right here. Okay, so what would you do? Well, you would go 3x plus 2, multiply that by 2x minus 1, and then you could subtract out x times x plus 3. Okay, now this would be a FOIL problem, a lot like the first two that we did. This would be a distributive problem, just like section 9.2, and then we'll look to combine like terms. I'm going to do this kind of fast here. 6x squared minus 3x plus 4x minus 2 is what you get when you multiply here, minus x squared minus 3x. Okay, well, here's like terms. That would be 5x squared. Here you have negative 3x plus 4x, that'd be x, minus another 3x would be negative 2x minus 2. And that's an expression, 5x squared minus 2x plus 2. That's an expression for the area of this figure. If you plugged in a real number for x, you can plug in a number for x, and you can plug it in here and actually calculate an area, and then plug in that same number here, you'd get the same area. If you want to try that on your own, try plugging in a 2 and then try plugging in 15 and just see if that you get the same thing. Okay, that is 9.3. Good luck on your homework.